Hello, welcome. I'm Ilan Niska. I'm a Microsoft Technical Trainer. This course covers 6 sessions where learners will build a foundational understanding of core data concepts and how data is stored, processed, analyzed, and visualized in Microsoft Azure. This session 5, we're going to shift our focus to explore streaming and real-time analytics. Let's get started. So far, we focus on working with data that's already stored, data you can query, analyze, and model after it has been collected. Streaming analytics is different. Here, data is generated continuously, often in high volumes, and needs to be processed as it arrives. Real-time analytics enables scenarios like monitoring live telemetry, tracking events as they happen, and reacting immediately to changes in data. This is especially important for use cases such as IoT data. By the way, Internet of Things, application logs, financial transactions, and real-time dashboards. In the next topics, we'll look at how Azure and Microsoft Fabric support that approach. Data processing is the process of converting raw data into meaningful information. In analytic solutions, there are 2 general ways this processing happens: batch processing and stream processing. With batch processing, data is collected over time and stored until it is processed together as a single group. Processing doesn't happen immediately. Instead, it runs at a later point based on a schedule, when a certain volume of data is reached or when another triggering event occurs. For example, imagine you want to analyze traffic by counting cars on the road. The batch approach will be like collecting all the cars in a parking lot and counting them later all at once. You get accurate results, but only after waiting for the data to be gathered. Stream processing works very differently. Here, each piece of data is processed as soon as it arrives. There's no waiting for a batch window. Data events are handled individually and in near real time, which makes this approach ideal for scenarios where data is constantly changing. Using the same traffic example, stream processing will count cars as they pass by in real time. You don't wait for all cars to stop before analyzing them. Instead, you can continuously aggregate the data. For example, tracking how many cars pass each minute. In practice, many large-scale analytic solutions use both approaches together. Stream processing is often used to capture and analyze real-time data, filter or aggregate it, and display results in live dashboards. At the same time, those processed results are stored so they can be combined with batch processed historical data. This allows organizations to analyze what's happening right now while also understanding long-term. Microsoft Azure supports multiple technologies for real-time analytics or streaming data. Azure Stream Analytics is a platform as a service solution used to define streaming jobs. These jobs ingest data from a streaming source, apply a continuous query, and write results to an output as the data flows throughout the system. For more complex scenarios, Spark Structured Streaming Services provides an open source approach built on Apache Spark. It enables advanced streaming solutions on Spark-based platforms such as Microsoft Fabric and Azure Databricks. Microsoft Fabric brings those capabilities together in a unified analytics platform. It includes services for data engineering, data integration, data science, real-time analytics, data warehousing, and databases. Streaming solutions typically follow the same pattern. An event generates data, the data is captured by the streaming source, the data is processed in real time, and the results are written to an output, also called a sink. Common streaming sources include Azure Event Hubs for high-volume event ingestion, Azure IoT Hub for Internet of Things device data, Apache Kafka for open-source event streaming, and Azure Data Lake Storage Gen 2, which can act as both batch and streaming source. Process results are often sent to event hubs for downstream processing, reading to storage such as Data Lake Storage Generation 2, OneLake, or Blob Storage, stored in databases like Azure SQL Database or Azure Databricks, or visualized in real time using Microsoft Power BI. For resource-intensive or high-throughput scenarios, Azure Stream Analytics also supports dedicated stream analytics clusters. These use the same processing engine as standard jobs, but run in an isolated environment with configurable scalability. Let's look at what real-time analytics actually means in Microsoft Fabric, because this is one of those areas where the architecture matters more than the feature list. Microsoft Fabric has a native support for real-time data analytics. That means it is designed to ingest, process, and analyze streaming data as it arrives, not after the fact. At the center of this is something called an event stream. An event stream is the way Fabric captures real-time event data coming from one or more streaming sources. Those sources could be things like application events, IoT telemetry, or system signals. The key idea is that the data is continuously flowing, not arriving in batches. Once the data is in an event stream, you decide where it should land. In Fabric, you can persist that to stream data into two main types of destinations: a table in a lakehouse or a table in a KQL database. If you write the data into a lakehouse table, you're typically thinking in terms of analytics over time. At this point, you can apply filters and aggregations directly in the event stream. That lets you summarize the data before it is stored, which is important for cost, performance, and downstream analytics. If you write the data into a KQL database, you're using the same data explorer engine that powers high-performance, time series, and log analytics. KQL databases are optimized for real-time querying, especially when you care about things that are like telemetry logs, event patterns. Once the data is stored, you query it using either SQL or custom query language KQL, depending on the destination you choose. The important point here is that the queries runs against live, continuously updated tables. Finally, because this data is already inside Microsoft Fabric, you can connect that to Power BI directly and build real-time visualizations. As new events arrive, the visuals update automatically. So the full list is streaming sources, send events. Event streams, captures, and optionally transforms this. Data is written to a lakehouse table or a KQL database, and Power BI consumes that data for real-time reporting. Architecturally, this is how Fabric connects streaming ingestion, analytics, and visualization into a single end-to-end real-time pipeline. Apache Spark is a distributed processing framework designed to analyze very large volumes of data. Instead of processing data on a single machine, Spark spreads the work across many nodes in a cluster and processes data simultaneously. In Azure, you typically use Spark through managed services rather than deploying it yourself. There are two main services where Spark shows up: Microsoft Fabric and Azure Databricks. In both cases, the goal is the same: scale data processing horizontally without you having to manage the underlying infrastructure. Spark can run code written in Python, Scala, or Java, and it works equally well for batch processing and stream processing. Batch processing means you already have a defined set of data and you process it as a unit. Stream processing means data keeps arriving continuously and your logic runs indefinitely as new data shows up. For streamer scenarios in Spark, you use Spark Structure Streaming. Structure streaming is Spark's way of treating streaming data as if it were a table that never stops growing. Under the hood, everything is built around structure called data frame. The data frame represents tabular data with rows and columns, regardless of whether that data comes from files, tables, or live streams. When you use structured streaming, Spark reads data from a real-time source, such as Kafka, a file system, a network socket, into what's called boundless data frame. Boundless simply means the data never finishes arriving. You then define queries on that data frame just like you would for batch data. You can filter rows, reject specific columns, or aggregate values, often using time-based windows. As new data arrives, Spark continuously applies the query logic and produces updated results. Those results are emitted as another data frame, which you can persist for further analysis, visualization, or downstream processing. This is where Delta Lake comes into play. Delta Lake is an open source storage layer that sits on top of Data Lake Store and adds database style capabilities. It brings transactional consistency, schema enforcement, and reliable updates to files stored in Data Lake. One of the most important aspects of Delta Lake is that it unifies batch and streaming data. The same Delta table can be written to by a streaming job and query later using batch analytics, or even serve as a streaming source itself. In practice, this means the Delta table can act as both a sink, where streaming data is reading continuously, and a source, where real-time data is read for additional streaming or batch workloads. Both Microsoft Fabric and Azure Databricks include built-in support for Delta Lake in their Spark runtimes, so you don't have to install or manage it yourself. When you combine Spark structured streaming with Delta Lake, you get a powerful architectural pattern. You can ingest real-time data, process it continuously, and store it in a data lake behind a relational schema. That relational abstraction matters. It allows analysts and downstream systems to query streaming and batch data using familiar SQL semantics without needing to understand how the data arrived or whether it came from a stream or a file. From an architecture perspective, this pattern is useful when you want a single, consistent storage layer or batch and streaming data, reliable transactional writes to a data lake, and SQL-based analytics over continuously updated datasets. Spark handles the distributed processing. Structured streaming handles the continuous ingestion and transformation. Delta Lake ensures the data remains consistent, queryable, and reliable. Together, they form a common backbone for large-scale analytics architectures in both Microsoft Fabric and Azure Databricks. Now we have a demo where we will explore real-time analytics in Microsoft Fabric. All right, let's open Fabric. Remember, this is the container for everything you create: event streams, event houses, dashboards. Let's create a new workspace. It can be any name. So let's apply that name. take a second. Now we'll need to create an event stream so we can ingest real-time data from streaming source. From the real-time hub, I'm selecting the yellow cub. This will be a sample data that I'm using for real-time analysis. We need to connect to the source. We give it a name for the source and a name for the event stream. And we are getting a combination of the two. See, taxi, data, stream, that's the name. Let's see it next. Now we will connect. It will take a second to connect. We can now open the event stream. And you can see the connection is done for us to query the data. You can see data is already coming in. This is real time. Let's create an event house where we can store that captured data in a table. So the event house will give you that durable storage and the KQL database so you can persist the stream and query it later. So we hit create. There it is, the KQL database that we can query. We will connect that to the data, get data, and we will select from the event stream. We'll give it a name. Select the workspace, the event stream. And next. Now you can see the preview of the data being connected. We check everything is how we want it. Finish. Yes, it is. So we created a very simple event stream that captures real-time data and loads that into a table. In a real scenario, you will add transformations to it. Let's close that part. We will query the captured data now. So let's select the table and KQL query. We'll create one. We'll remove the contents here and add our own query. Take the first 100 and you can see the values are coming, are stored, persisted, and we can query them. We can play with a KQL and make a different query as well. Here we are summarizing, counting. You can see it is pickup count. Yeah, that's it. Let's stop for a quick knowledge check to validate two core ideas about real-time analytics. First question, which definition of stream processing is correct? And the correct answer is that data is processed continuously as new data records arrive. That's the key distinction between streaming and batch processing. With streaming, data is handled as it flows in rather than being collected and processed later as a group. Second question: which component of Microsoft Fabric provides a central place to manage streaming data? The correct answer is Real-Time Hub. The Real-Time Hub is where streaming sources, event streams, and real-time data flows are surfaced and managed in a unified way across Microsoft Fabric. If you understand these 2 points, you have the right mental model. Streaming processing means continuous processing, and the real-time hub is the control center for streaming workloads in Fabric. At this point, it's useful to step back and connect the pieces. Real-time analytics is about working with data that arrives continuously, and Azure offers multiple ways to do that depending on the scenario. This concludes our session. We hope you will join us as we journey through this course. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.